Algebra. Mr. Lawrence here with your flipped lesson. This is the one you're supposed to watch before we come back to school on April 10th. That's why it's dated April 10th. I guess I should date it April 9th, but it's the one over spring break. Anyway, today should be a super easy lesson. We are going to talk about something called radicals. Radicals. Oops, there's an extra little symbol in there. Sorry. Writing with the airliner. You know I'm learning how to do it. By the way, some of you may have noticed an extra little lesson posted. You can watch that if you want. It'll help you get ready for the final exam right after we get back from DC. All right, now a radical. What is a radical? A radical simply is the positive square root. Remember that the square root of 4 does not equal 2. It equals 2 or negative 2, or if you're lazy like me, you might have written it plus or minus 2. Every square root has a positive and a negative. Well, the radical is the positive, and that's why in the quadratic formula it's negative b plus or minus the square root of b squared minus 4ac, and the whole thing is over 2a, right? We use that to find the roots. But notice there's a plus and a minus there. We're going to be talking about positive square roots. Now, I know some of you are thinking, oh, I'll just punch it on my calculator. And thank you for playing. We will not be using our calculators for this. Positive square radicals, as they're called, positive square roots, we like to use in exact answers. Now, before we do, I first want to talk a little bit about the number line and say, you know, if I have this big or long number line, kind of like this, and let me see here. Okay, I have a big old long number line like this, and most of you realize that, you know, these are the integers I'm showing, negative 1, 0, 1, 2, 3. Of course, they have no beginning, no end. They go on infinitely in both directions. And most of you realize there are numbers between here. Some of the numbers in between there are the form of radicals. For example, I could put on here that the square root of 0 is the same as 0. And the square root of 1 is 1. But the square root of 2 does not equal 2. It's the square root of 4 that equals 2, right? Then there's a square root of 9. These are my perfect squares, right? Square root of 16. Now, what a lot of you don't realize is that there are irrational numbers sandwiched in here. The blue ones are all rational. There are numbers that can be expressed as a fraction. They are numbers, decimals, that end or repeat, or you could say terminate instead of end. So the blue ones are all examples of rational numbers. But in between these rational numbers, there are some irrational numbers. For example, like the square root of 2. There is no exact square root of 2. You can get a decimal approximation of it. Okay, 1.414, blah, 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 blah. 1.41, excuse me. Blah, blah, blah. Keeps on going. And the square root of 3 is in here. It is also irrational. The square roots of 5, 6, 7, and 8 are all sandwiched in between the square root of 4 and the square root of 9. And remember, I can use those skills to help me estimate the square root of 8 or the square root of 5. Like, for example, I know the square root of 9 is 3. The square root of 8 is pretty darn close to 3. It's going to have to be in the high 2s. There's 4 numbers in between. I'll bet you it's going to be like a 2.85 or a 2.9. Okay, estimation skill. You can check that on a calculator for me. Between here are all the rads of 10, 11, 12, 13, 14, and 15. Okay, and so on. And notice how between each pair of perfect squares, like this one didn't have anything from 0 to 1. There's no rads in there. This one had 2, this one had 4. Let's see if we go 10, 11, 12, 13, 14, and 15. We're up to 6. All right, 6 in between here, and it keeps increasing as you go and go. All right, now remember, the blue ones are rational numbers, the red ones are irrational. All right, irrational numbers are like pi. Pi is the most famous of irrational numbers, but certainly it is not the only one. All right, let me see here. Now, when we do rads, let me bring this down. I love to think of dating. Yes, you heard me right. I love to think of dating because I think of this as being the house. And let's say I had a number, say like, I don't know, 200. And I wanted to simplify the rad of 200. Well, I could break this down into 100 times 2. I could have broken it down a lot of ways. I chose 100 because it was the largest perfect square that I knew was a factor of 200. I'm going to say that again. 100 is the largest perfect square that is a factor of 200. That's why I broke it down as 100 times 2. Not because it's easy to divide by 2, because 100 is the largest perfect square. You want to review your perfect squares again, that might be a good idea. I'll come back to that problem in a second. Perfect squares, well, I got 1, 4, 9, 16. If you don't remember, this is 1 squared, 2 squared, 3 squared. I'm just going in order. 4 squared. So think 5 squared is 25. 6 squared is 36. 7 squared is 49. 8 squared is 64. Oh, where are we at here? 9 squared, 81. 10 squared is 100. 11 squared, 121. Oops, 121. 12 squared, ooh, that's gross, 144. 13 squared, 169. 14 squared, 196. That's a hard pair to remember. Okay, 15 squared, 225. 16 squared, I always screw up on 16 squared. Hold on one sec. Yeah, it's got to be 256. Okay. Where are we at here? 17 squared, 289. 18 squared, 324. 19 squared, 361. 20 squared, 400. If you know those, you're going to be pretty good. If you just say them over and over and over again to yourself in order, after about 10 or 15, maybe 20 times, as smart as you guys are, you will definitely start to remember them. So let me get back to my problem here. And I know that 100 is the largest perfect square. Now you can pick any perfect square, but I'm telling you, pick the largest one. So I can rewrite this as 10 times 10 times 2. And here's where the dating part comes in. Usually for a date, you need a pair, right? You need one boy and a girl. 2 of the same kind. Now we're going to be a little bit of prejudice here with the numbers. The numbers are not allowed to date outside of their value. So for example, 10s can date 10s, 5s can date 5s, 7s can date 7s, 3s cannot date 2s, 1s cannot date 15s, etc. So you see these 10s here? Those 10s get to leave the house and go out on one date. So the 10s are outside the house. Oh, there's the house. Now this 2 doesn't have a partner, does he? He's left and stuck inside. So the simplification of rad 200 is 10 times rad 2. It means 10 times the square root of 2. 10 rad 2 is how we say it in a math circle. All right, let's try another one here. Let's do, say, hold on one sec. Okay, let's try 192. The rad of 192. Well, I know 100 doesn't go in, so I'm going to back down to 81. 192, let's see, let's count by 81. 81 and 81 is going to be 162. Another 81 is going to be more, so I know 81's not going to go in. Let's try the next lowest, 64. 64 and 64 would be 128, and another 64 would have 2, carry the 1. That's a 9. Oh, look, it goes. All I did was add 3 64s together. 3 64s make 192. I know that rad 192 can be broken down into 64 times 3. Now I know 64 is a perfect square, so I can break this down further. Rad 8 times 3, like this. All right, and look at that. I've got a date. My 8s can go out on a date. This pair of 8s can leave the house and go out on one date. 3 is left at home washing his hair. 8 rad 3 is the simplification of rad 192. This is pretty easy stuff. It's easier if you know your multiplication facts. All right, let me give you one more example. How about the rad of 175? Well, I'm going to look and say, hey, I know 25 is going to go in there. I don't know if it's the biggest perfect square that's going to go in there, but I'm going to try it. 25, and I know if I had, how many quarters would it take to make $1.75? Well, I think it would take 7. I'm going to break this down into 5 times 5 times 7. Got a pair of 5s. They're going to leave the house on one date. 7's left at home washing his hair. Okay. Now, if you're not so strong with your multiplication facts, like I know some of you are not, you can take a situation, say like this, 80, square root of 80, or rad 80, and you can break it down into all its factors, okay, the prime factorization. In fact, I'm going to do that over here. I'm going to go 8 times 10, and I know 8 is 2 times 4, and I'm going to underline every time I get down to a prime number. 4 is 2 times 2, okay, 10 is 2 times 5, and the trick is you have to underline everything that gets to a prime number. Okay, every time you get a prime number, you have to underline. So it looks like I have 2 times 2 times 2 times 2. Looks like there's 4 2's underlined, and then a times a 5. Okay, so now when I have a situation like this pair of 2's can go out on a date, and this pair of 2's can go out on a date. And notice I multiply them. Of course, I'm not going to have 22 outside the house because I didn't have a pair of 22's go on a date. I have one pair of 2's and another pair of 2's. So it's like having a pair of 4's. The 5 is left at home. And I can say, better yet, that this is 4 rad 5. There is the simplest answer. You don't need a plus or minus because we're dealing with the rad, which again is the positive square root. All right, I'm going to give you a couple examples. Hold on one second. Okay, see those 4? Rad 8, rad 27, rad 300, and rad 1750. Go ahead and pause the video, see what you can do with them. And we're ready to see my solutions. Go ahead and unpause. If you're still watching at this point, I'm assuming you want to see my solutions. I'll start with number 1. I know rad 8 is the same as 2 times 2 times 2. Could have said 4 times 2 if I wanted. I've got a pair of 2's that get to leave the house on one date, and there's a 2 left inside. So my answer, simplified answer, is 2, rad 2. Okay, rad 27. I can think about rad 27 as 9 times 3, and then I can break that down further as 3 times 3 times 3. These 3's can leave the house on one date. I'll have 3 with a rad 3 left inside. And there we go. This stuff's easy. All right, number 3. It's the same as one of the examples I did because I can say, well, that's 100 times 3. And I'm going to get real lazy here. I know that the rad of 100 is 10. And then there's a rad 3. Now, some of you are going, wait, Mr. Lawrence, you didn't do it the same way. Well, some of you know the rad of 100 is 10. You don't have to do the dating thing. The dating thing is just to demonstrate what's showing, what's going on. It's just a little trick. All right, if you understand what's going on, you can do it a little more simply. I wouldn't skip any more steps than that, but that is one possible way to do it. All right, rad 1750. I know 100 doesn't go in. I'm willing to bet 25 goes in. Let me see here. How many times? 1750. I'm going to divide by 25. And I know that 25 does not go into 17. It does go into 175 7 times. And that'll go evenly, I believe, right? 175 on the nose. Yeah, and then when I subtract, I'm going to get 0. 25 goes into 0 times. 25 times 70. which just doesn't look right to me. Hold on, let me check my math. Okay, I'm convinced that that's okay. It bothered me, but I checked my work for a minute, which is a good thing to do. Now, I know that 25 is 5 times 5. 70 could be 7 times 10, or 7 times 5 times 2. So, these 5s are going to leave the house and go out on one date. I'm going to be left with 7 times 5 times 2. Now please be smart. We know that 70 was 7 times 5 times 2. Don't sit there and rethink 7 times 5 is 35 times 2 is 70. You should already know that. There's a 70 stuck at home washing their hair. All right, that's the lesson. It should be really easy. When I see you on Tuesday morning, we'll do some formative assessments. Those of you ready for the homework, you'll just tear into it. You probably won't have homework Tuesday night. All right, Mr. Lawrence signing off. Good night, everybody.